In this lesson, we'll be talking about capacitors connected in parallel, capacitors connected in series, and capacitors connected in series parallel. So, capacitors connected in parallel, we have to consider these two things: voltage and electric charge. Voltage is common, it means voltage is the same across each capacitor in the parallel circuit. And electric charge varies, it means the individual capacitors or the electric charge across each capacitor in the circuit varies. That is what it means. Before that, we have to consider these formulas. Everything that we'll be doing, we'll be using these three formulas here to guide ourselves. So Q is charge, V is voltage, and then C is capacitance. That is, C is equal to Q over V, whereby C is equal to capacitance, Q is equal to charge, and V is equal to voltage. Capacitance is equal to electric charge over voltage. If you are looking for electric charge, we have to do cross multiplication. This any alphabet or number standing alone is over 1. So C here is over 1. So cross multiplication, C times V here. Then Q times 1 is the same number. Therefore, Q here is equal to C times V. Now, to look for V, we have to divide both sides by C, divide both sides by C. C will cancel C. V is equal to Q over C. So we'll be using these formulas here to consider or support ourselves or guide ourselves throughout the calculations. So this is a simple circuit whereby the capacitors are connected in parallel with a supply voltage here, a battery. So capacitor 1, capacitor 2. And now, if capacitors are connected in parallel, to calculate for the total capacitance or the equivalent capacitance in the circuit, it is the addition, the summation of all the individual capacitors. I repeat, I said capacitor 1, capacitor 2 here. In this circuit, the capacitors are 2. So for you to calculate for the total capacitance, if they are more than 2, and you want to calculate for the total capacitance, it is the addition. It means adding C1 plus C2 plus C3 plus C4 in that order. So if they are more than that, it is the summation of all. Here they are 2. So it is the summation of capacitor 1 and capacitor 2 for you to get your total capacitance or your equivalent capacitance. This is the supply voltage, which is the supply voltage is 6 volt. C1 is 20 nanofarad. C2 is 10 nanofarad. Capacitance. Capacitance C is measured in farad. Electric charge Q is measured in coulombs. Coulomb. So if it is 1, it is 1 coulomb. If it is 2, it is 2 coulombs. Voltage V is equal to, is measured in what? Volts. So if it is 1, it is 1 volt. If it is 2, it is 2 volts, in that order. So now I calculate the equivalent capacitance to the total charge the voltage across each capacitor, that is V1, V2, V3, that is if the capacitors are more than 2, more than 3, more than, it means that we'll calculate for V1 voltage, V2 voltage, V3 voltage, or capacitor 1 voltage, capacitor 2 voltage, and capacitor 3 voltage. That is the voltage across the capacitors. So the total charge the energy stored on each capacitor. So normally it's in the form of U. So you can see that it is U, but not all that clear. So this is the unit. And energy is measured in joules. Energy is measured in joules. So let's come back here and add energy. We'll consider this one, which is in what? Joules. Joules. J. So if you don't want to use this, this is in what? Capital F. This is C. This is V. And this is J. So solution I. Total capacitance or equivalent capacitance in the circuit. You know that the total capacitance or the equivalent capacitance is equal to C1, so plus C2. Now, here the standard unit of capacitor always have nanofarad, picofarad, and then microfarad and millifarad in that order. So here the standard units are the same. So we'll say that C1 is 20 plus C2 is 10, which is equal to 30, then nanofarad. This is the total capacitance or the equivalent capacitance in the circuit. 2. We'll be looking at the total charge. Total charge QT in the circuit. We know they have the formulas are 2. So QT can be considered as equivalent capacitance times the supply voltage, whereby the equivalent capacitance is 30 bracket open 30 times 10 raised to the power minus 9, that is the nano, times the voltage, which is 6 volts. So we'll put our calculations here, then we see the answer. We have bracket open 30 times 10 raised to the power or 10 exponent 9 bracket close times 6 times 6. We see that our answer is equal to 0. The zeros as 0.01234561 then the answer is in what? Coulombs. This is our answer. So we are moving. So this is total charge is equal to 0.00000018 coulombs. So we want to confirm that this answer is correct or is correct, right? So we can also use Q1 formula, whereby we know that Q is equal to CV, but we are working on capacitor basis. So here we'll take C1, which is C1 times what? V1. And we know that voltage is common here. Voltage is common in this particular circuit, that is parallel circuit. Voltage is common. So Q1 is equal to C1 V1. But V1 is equal to 6 volts. Are you aware? You know that V1 is equal to 6 volts, which means Vs is equal to V1 equal to V2 equal to V3 in that order, which means voltage is what? The same. So if Vs is equal to 6 volts, it means V1 is equal to 6 volts, V2 is equal to 6 volts in that order. So I'll prove this for you. Let's proceed. So let's proceed, and I'll come back to prove to you that it's true that V1 is equal to 6, V2 is equal to 6. So here Q1 is equal to C1 V1, whereby C1 is equal to 20 times 10 raised to the power minus 9, that is 20 nanofarad, times 6 volts. So Q1 is equal to what? So bracket open, 20 times 10 raised to the power of 10 exponent negative 9 times bracket open 6 volts. We have 0.12345612 coulombs. We have Q2. Because we are working on capacitor basis, we are working on capacitor basis, we are using Q2 here. We are using C2 V2, which is equal to C2. We know it to be 10 times 10 raised to the power minus 9 times 6, because it's 10 nanofarad. So a nano is 10 exponent minus 9. So when we come to our calculation here, we only take away the this, and you know that Q2, you see that our answer is 0.00000. The zeros here are what?